At CellGate, we specialize in providing state-of-the-art access control solutions that leverage the power of radio frequency, or RF technology. Our flagship products, the Watchman series and OmniPoint line, are designed to offer reliable, secure, and convenient access control for a wide range of applications, from residential gates to commercial and industrial facilities. These systems utilize specific radio frequency bands allocated for access control, enabling them to communicate wirelessly and effectively without the need for physical connections. In this video, we'll dive deeper into the fascinating world of radio frequency and explore how it forms the backbone of CellGate's cutting-edge access control systems. In our modern world, wireless communication has become ubiquitous, enabling devices like smartphones, laptops, and even access control systems to communicate without the hassle of physical cables. This is made possible using radio frequency, RF signals, which are a type of electromagnetic wave that can travel through the air. Every wireless device has an antenna responsible for sending and receiving these radio waves. The antenna converts electrical signals from the device into radio waves that spread outward in all directions. Imagine dropping a pebble into a still pond. The pebble creates ripples, or waves that spread outward from where it landed. Radio waves work in a similar way. They spread outward from the antenna in all directions, like the ripples on the pond. These radio waves have specific frequencies measured in cycles per second, or hertz. The range of frequencies from 3 kHz to 300 GHz is referred to as the radio frequency, RF range, and it is utilized by various wireless communication technologies, including televisions, radios, radar systems, Wi-Fi routers, and access control systems. For two wireless devices to communicate, they must be operating on the same frequency or channel. The transmitting device sends radio waves at a specific frequency, and the receiving device must be tuned to that same frequency to pick up and decode the signal. In the context of access control systems like CellGate's Watchman series and OmniPoint line, RF signals play a crucial role in enabling wireless communication between devices. These systems operate on specific radio frequency bands allocated for such applications to prevent interference with other wireless technologies and ensure reliable communication. When a user interacts with a CellGate access control device, such as presenting a credential or entering a code, the device converts this input into digital data. This data is then modulated onto an RF carrier wave and transmitted from the device's antenna as a cellular RF signal. This signal can travel through most materials, including walls and obstacles, but its strength and quality can be affected by factors like distance, interference, and environmental conditions. On the receiving end, a cell tower picks up the transmitted RF signal and relays it to CellGate's TrueCloud Connect and your CellGate app, allowing you to send commands to open the gate or take a video call. Because RF signals can be negatively impacted by certain factors, proper site surveys and careful planning are essential when installing CellGate's access control systems that rely on this communication to ensure seamless operation and reliable access control. In summary, radio frequency signals are the backbone of wireless communication, enabling our modern, untethered lives with devices like smartphones, laptops, smartwatches, and internet-enabled appliances. In the world of access control, RF technology allows CellGate systems to provide convenient and flexible installations without the need for wired connections, ensuring secure access control while leveraging the versatility of wireless communication.